Hello students and welcome to Chemistry B. I'm Miss Slate and today we're going to talk about how we can determine the empirical formulas of compounds. You can continue to take notes in your notebook like normal, or you can feel free to follow along on page 9 of your stoichiometry packet. First off, some elements can form more than one compound with each other. One great example is hydrogen and oxygen. They form two common compounds, water and hydrogen peroxide. The only thing being different about the two is the ratio of hydrogen to oxygen in each. If we compare the mole ratio of each element in a compound, we can determine what the empirical formula for that compound is. So a given example would be a sample of a compound contains 11.2 grams of iron, 21.3 grams of chlorine. What is the empirical formula for this compound? Well, the steps to figuring that out is, number one, determine the moles of each element. So we're going to have to convert from grams to moles for iron and chlorine. Then we need to find the ratio of moles for each element. And we're going to be doing the ratio of whichever one has the smallest number of moles will go on the bottom. And I'll show you that in a second. And then we're going to express that ratio as a simple whole number ratio and use that ratio to write the chemical formula. So let's work through this example. So again, first off, we've got 11.2 grams of iron, 21.3 grams of chlorine. So my first step for each of these is going to be to convert from grams to moles. So I'll do iron first. 11.2 grams of iron. We want moles. We have mass. The molar mass of iron is in 1 mole. There are 55.933 grams. Units of grams cancel. And to get my answer, I'd do 11.2 divided by 55.933. Rounding to correct significant figures, we get an answer of 0.200 moles of iron. Then I convert my mass of chlorine to moles. So 21.3 grams of chlorine over 1. I want moles and I have grams. The molar mass of chlorine is 35.453 grams in 1 mole. Units of grams cancel, and 21.3 divided by 35.453 gives us the answer of 0.601 moles of chlorine. Now that we've converted them from grams to moles, we find the mole ratio. So we're just going to take whatever the bigger amount of moles is and divide it by the smaller amount of moles. So in this case, that is these 0.601 moles of chlorine divided by 0.200 moles of iron. That gives us an answer of 3.01. Now, we want to round this to the nearest whole number so we can make it a whole number ratio. Well, the closest whole number to 3.01 is 3. To make it a ratio, we've turned it into a fraction, 3 to 1. So this tells us we have 3 parts chlorine to 1 part iron in this formula. So then we would write the chemical formula, which would be FeCl3. Again, because we know we have 1 part iron to 3 parts chlorine in the compound. Let's look at a second example. So sometimes they give us our empirical formulas in terms of percentages, like this example, that says if a compound of phosphorus and oxygen is found to be 43.7% phosphorus and 56.3% oxygen, what's the empirical formula? Well, here's what you do with the percentages, all right? All percentages add up to 100%. So 100% of the compound is divided into 43.7% oxygen, or of phosphorus, and 56.3% oxygen. So what we do is we assume that our total sample is 100 grams if we're dealing with percentages. And then we can just say we have 43.7 grams of phosphorus and 56.3 grams of oxygen. Again, because our percentages add up to 100, if we assume the sample is 100 grams, we can just work from those numbers. And so once again, first thing I'd do is I'd convert to moles. 43.7 grams of phosphorus moles over grams to cancel grams. Phosphorus has a molar mass of 30.974 in 1 mole. Units of grams cancel. And we do 43.7 divided by 30.974. And rounding to correct significant figures, we get an answer of 1.41 moles of phosphorus. Then we do the same thing for oxygen. 56.3 grams of oxygen. The molar mass of oxygen is 15.999 grams in 1 mole. Units of grams cancel. And then 56.3 divided by 15.999. Rounding to correct significant figures gives us an answer of 3.52 moles of oxygen. Again, next thing to do is to find that mole ratio. So in this case, we're going to do moles of oxygen over moles of phosphorus, just because we're always putting the smaller number on the bottom. So 3.52 moles of oxygen divided by 1.41 moles of phosphorus gives us an answer of 2.50 exactly, which is really convenient because 2.5 is a simple whole number ratio, right? 2.5 is the same as saying 5 over 2. So this tells us that our compound is 2 parts phosphorus and 5 parts oxygen. So we would write its chemical formula as P2O5, and that would be the empirical formula. So now you know how to determine the empirical formula of a substance when you're given either the mass of the elements in it or the percent composition of the elements in it.